Welcome to Geometry Pre-AP. This is Topic 1, Section 2, Day 2. This material actually can be found in the textbook in a different place. You can find this material in Chapter 5, which we call Topic 5, Section 1. So Topic 5, Section 1, if you want to go look in your book for more help on this topic. And so it's finding the distance in the midpoint on a coordinate plane, and then use midpoint and segment bisectors with segment addition postulates. Okay. So our essential understanding is you can derive the formula to find the midpoint and the length of a segment in the coordinate plane. This will help you verify geometric relationships. That right there, this will help you. That is the key to this. We're going to use it all throughout the semester to verify geometric relationships. That's why I pushed it to now, to make sure you learn it now so we can use it throughout the semester to verify different relationships, and it'll be a big part of every test. Okay, so the midpoint of a segment is the point that divides a segment into two congruent segments. So when you have a midpoint like right here, it basically means that you have part is equal to part, not part plus part is equal to whole. It could be that if they told you what the whole was. So make sure you read each question carefully. So that doesn't mean you don't ever use part plus part is equal. It means you just don't necessarily use it every time. All right. And then a segment bisector. I'm going to get rid of this word. Is a ray, a line, or a line segment or plane that intersects the segment at its midpoint. Okay. So I also call a segment bisector a midpoint detector. It just tells you where the midpoint is. The midpoint divides the whole segment into two congruent segments. It's just a midpoint detector, just tells you where the midpoint is. That's all a segment bisector does. So remember that. This can be important when we start doing proofs, and it's going to cause you lots of problems if you don't remember this written part here. All right. So here we have a little problem to do. It says line RS bisects PQ. So we actually need to start with P and Q. So here's segment PQ because this has a beginning and an end point. And it said RS bisects. Remember we said that a bisector just tells us where the midpoint is. It even tells us that point R. So it just told us that R was the midpoint. Now we don't know where S is. But we do know that it tells us where the midpoint is. So S can be above or below. So I'm going to go ahead and put it below here. It just makes it easier to see. So it tells us in this problem that if PQ, so from here to here, is 14, find RQ, which is this one we don't know. So PQ is equal to 14. RQ is equal to 14 divided by 2. So it's 7 centimeters. We want to write this and this. No bars over the RQ because it's not necessarily a segment, it's just a distance. And we don't put a bar over a segment thing when we're representing distance. So I want you to do this one in your notes so that you can show that to me. And make sure you have the one above it. All this needs to be in your notes. So pause the video and do that one. Draw your picture, show your work. Okay, so you should have that problem done. Let's move on. So now we're going to look at it from an algebraic standpoint. So it says point M is the midpoint of VW. Find the length of VM. So we're looking for this. Now, normally I won't give you this information in the picture. You have to draw your own picture, put all the information. They were even nice to put the congruence marks in there. I'm not going to do that for you. You're going to need to be able to put that in yourself. So if it's a midpoint and those two pieces are congruent, we don't have part plus part is equal whole because we don't know what the whole is. So this is out. This is our setup. Part is equal to part. So pause video, solve this, plug it back in, and see what you get for your answer. Okay, so you should start video. So let's just go through this. I think there's a little typo here. This really shouldn't be a positive one. It should be a negative one. Maybe you caught that. Maybe you didn't. Maybe that's why you're having some issues with this problem. So minus 3x. That's why I'm going to finish working. Plus 1 and plus 1. So when I get this, I get x is equal to 4. If you got x is equal to 2, probably had some issues at the top because the two segments weren't the same, and that should give you an idea that something was wrong. So I got 4 times 4 minus 1, so 16 minus 1, which is 15. And then 3 times 4 plus 3, so that's 12 plus 3, which is 15. And so I can say Vm is equal to 15 units. I don't know a unit this time, so I have to just use the general term units. Okay, and that's the answer we do there. All right, so I'm going to pause this video here. I want you to do this problem. Make sure you have the problem in your notes and all your work there. All right, so you should have this problem worked out. You should have a solution. You should have what PR is equal to. Don't forget your word for units. If you have a problem with this one, make sure you ask when you come to class the next day. All right, so midpoint formula. So we're moving kind of from Euclidean into a coordinate plane work. And so when we do this, we have x's and y's all the time. And so we have ordered pairs. The midpoint formula is x1 plus x2 all divided by 2, comma y1 plus y2. Now there is a Schroederized version of it, okay? And the Schroederized version is just me making things easier for everybody. That's kind of what I do usually. And remember it as the average of x and y coordinates. Because how do you average something? Well, you add them and divide by the number of things you have. Well, if you have two x values, you add the two x values, like right here, and divide by 2. And if you average the y's, there's two y's, so you add them and divide by 2. So if you forget the formula, remember it's the average of the x's and y's. I'm going to ask you for some formulas on the test, and if you can't tell me the formula, you're going to lose some points. So again, I'm telling you what you need to know for the test. All right, so let's do some practice. It says find the coordinates of the midpoint of the segment given with the given endpoints. So x1, y1, x2, y2. It's an average of the x's, so -7 plus -3. Don't subtract. It's adding divided by 2, and then the y's, -5. Oops. -5 plus 7 divided by 2. So that's -10 divided by 2, which is -5. And this is 2 divided by 2, which is 1. And this is my midpoint. Put an M in front of it to represent midpoint. All right, so this one's for you to do. So pause the video and do that one. All right, you should make sure you have some work there for that problem. We'll be checking for that the next day. All right, so now finding endpoints. Use the given endpoint R, so this is an endpoint, and the midpoint M, and find the coordinates for the missing endpoint. So what we have this time is we have a segment. We know R, we know M, but we don't know where S is. And so it's just unknown. We don't know where it is. And so you could work the formula and solve for each one, but I like to do things the easy way. I'm always about working smarter, not harder. So I like to take a little table here. All right, and so we have R, we have M, and we have S that we don't know. So R that tells us is 6, -2. So this is my X and my Y. My M is 5, 3, and I don't know what my missing S is. So remember that midpoint's in the middle, so if we know how to get to the middle, we can find out how to get to the end. So how do I go from the 6 to the 5? I subtract 1. Well, if that's in the middle, I have to do it again on the other side. If I subtract 1 from 5, I get 4. And if I go over here, how do I go from -2 to 3? That's going to be plus 5. So if I add 5 again, that's going to be 8. Well, there's my answer. S is 4, 8. And so this is a table. This is showing work. This is what you need to be able to provide on tests and things like that. All right, so try the next two and have those in your notes for when you come to class. You may pause the video and do those. All right, so just to give you another answer here, just to check with this one, I'm not going to give you the last one, but I will give you this one. So -3 and 7. And so you'll need to have this one over here also, okay? But you better have the work. If you just have that answer, it's not going to get you any credit. All right, so distance formula. here is the distance formula. You can pause the video and write this down if you'd like. I'm never going to make you use it in my class, because there's a lot of easier ways to do this, okay? But this is the formula. And if you look over here, there's a great picture that kind of illustrates it, that, you know, this distance right here and this distance right here is in the problem. But this whole entire thing is a right triangle. And so if it's a right triangle, I like to use Pythagorean theorem. That is just a lot easier. Where, when I'm using Pythagorean theorem, let me switch my pen here, that this represents the A, this represents the B, and the distance from A to B is the part C. And so Pythagorean theorem is going to work so much easier for everybody, and it makes it go a lot faster. So if I look at this problem, I want to find the distance from Q to R, and so I can connect, and I can make a nice right triangle as. So the distance here is 2. Distance here is 3, 4, 5. And so this is my unknown, which is my C in my formula. So I have 2 squared plus 5 squared equals C squared. And so that's 4 plus 25 equals C squared. So C is equal to the square root of 29. Now, in geometry, we're going to make sure that you can simplify that radical. That was part of the summer packet, that you should be able to simplify that radical. So if you're still having problems with simplifying radicals, we'll try to put a review of that in the summer packet review videos. Okay, so this one over here is for you to practice. All right, so you may pause the video and get that one done. So for this one, the distance from P to Q, you should have 2 square root of 5. That's a simplified radical. Better have all the work there. Okay, now we don't always give you a coordinate plane, and so you can't always draw the little right triangle in to do all your numbers like this one right here. So what do you do when you don't have a coordinate plane? And the answer is no, you don't draw one and create it. So here's what you do. Okay, here's a find the length of the segments. So how do I go from a -1 to a 3? Those are the x values on a coordinate plane. And you should be telling me the distance between those is a 4. How do I go from a 2 to a -2? You should be telling me the distance between those is 4. So those are my two numbers for Pythagorean theorem. So that's 16 plus 16 equals C squared. So that's a 32 equals C squared. So C is equal to 4 square root of 2. And that's the simplified version. So you need to be able to do it even when you don't have a coordinate plane. Matter of fact, you need to really be able to do that and quickly. Okay? So I just kind of threw this on the page to make sure that everybody could see the definitions and the topics that we needed to make sure we cover. And so I'm going to shrink that up a little bit so that you can see it all. And that wraps up our lesson for today.